Alright, so hopefully your solubility curves look like this. This is my pretty graph. And so we're going to kind of look at the part 1 questions, so hopefully you have that in front of you. But the first question says, how does the solubility change over the temperature range for KCl, LiCl, and NH4Cl? Potassium chloride, lithium chloride, ammonium chloride. And you can see for those three on my graph, they are all increasing over the temperature range. Question 2, HCl, hydrochloric acid, hydrogen chloride, is decreasing. And the difference is, I hope you remember we've talked about, but potassium chloride, lithium chloride, ammonium chloride, those are ionic compounds. HCl, hydrogen chloride, hydrochloric acid, is a molecular compound. And so that's why we see as the temperature of water goes up, then the HCl solubility goes down. And question 3 says, what mass of each of the chlorides will dissolve in 100 grams of water at 50 degrees Celsius? AKA, what are the chlorides' solubility at 50 degrees Celsius? So I go and find 50 degrees Celsius. That's this line right here. And then I figure out where the chlorides, their curves hit that line. And that is the solubility. So for KCl, my red line, boom, right there, that's about 43 grams. 43 grams. For lithium chloride, that's my blue line way up here. Oh, it's about 94 grams. Ammonium chloride, boom, right there for me is at the 50 gram mark. And then HCl right there, oh, let's call that 58 grams. Your answers might be slightly different looking at your graph, but that's how you want to answer that question. I want to clear that. Question 4, at what temperature will the same amount of HCl and KCl dissolve? Well, I'm going to try and find where those two lines cross. So HCl is green, KCl is red, and boom, right there. So I'm looking at a temperature of about, I'd say 72 degrees Celsius. That sounds about right. Now, question 5. This one can be a little tricky. Now, these curves represent the saturation line. So, for lithium chloride, this is the amount of solute that goes into the water at those temperatures to make a saturated solution. So, above the line represents supersaturated solution data. Okay, because if you have more than the maximum, that is a supersaturated solution. Any data below the line represents unsaturated solutions because you have less than the maximum amount. So again, the line represents saturated, data above it is supersaturated, data below it is unsaturated. So looking at question 5, if I dissolve 55 grams of each chloride at 60 degrees Celsius, so here's 60 degrees Celsius, I go up to 55 grams, and that's this big dot right here. So is the solution saturated, unsaturated, or supersaturated? Well, for KCl, I can see here's my KCl line. At 60 degrees Celsius, I should only be able to put 45 grams of KCl in. So if I somehow have 55 grams in, that's more than the maximum. So that is supersaturated. Okay, so that meant I had to trick that solution. I had to heat it up, dissolve it, and bring it back down. And so when the data point is above the line, that represents supersaturated. Lithium chloride at 60 degrees, way up here, I can put almost 100 grams of lithium chloride in. So this data point 55 is way below that line. So that is unsaturated. I can put a lot more solute into the water before I hit saturated. And then for ammonium chloride and hydrochloric acid, right there on the line. So both of those solutions would be saturated because, again, any point on the line is saturated. So just be careful with that one. If the data point is above the solubility curve, let me highlight that for you. So if I'm looking at this curve, if the data point is above it, that's supersaturated. If the data is below it, that's unsaturated. If it's on the line, saturated. All right. Question 6. If you made a supersaturated solution of potassium chloride at 80 degrees with 70 grams, well, let's go find that point. 80 degrees Celsius, 70 grams, and so boom, right there. Right there. Well, that would be supersaturated because here's KCl, and at 80 degrees I should only have right there about 50 grams. So that's definitely a supersaturated solution. Well, now if you drop a seed crystal in, you're going to get all the extra solute to precipitate out. And so the question there is, how much? Well, up here we're at 70 grams. And as soon as you drop that seed crystal in, it's going to go back to being saturated. So it's going to go back to the line. And so we had 70 grams in there. It goes back to 50. And so the difference is 20 grams will precipitate out. All right. And so again, supersaturated down to saturated, the difference will precipitate out. All right, last questions to look at. This graph is set at 100 grams of water. And so all of these different data points reflect how much solute we can put in 100 grams of water. Well, question 7 says, well, what if we don't want to make 100 grams or 100 milliliters of solution? Well, then we need to adjust it. So 7a says, I want to make 50 grams of a saturated solution of HCl at 20 degrees. So 20 degrees for HCl, there's my data point. That's 73 grams. So what this data point means, again, is, I'm trying my best to write with my mouse, 73 grams of HCl in 100 grams of solution or water. Close enough. Well, if I only want 50 grams of solution, then your brain should hopefully logically say that's half. So instead of 73 grams of HCl, I only need half of that, 36.5. And you are correct. If you would prefer to draw it out for you, we're just solving a proportion. How many grams of HCl would I need in order to make 50 grams of solution? And so then I have to cross multiply 100x equals 3,650, divide by 100, and either way, 36.5 grams of HCl is what we would need. Now if the question had said, I want to make 200 grams of solution, then I would double it. 73 times 2 is 146. If it says 500 grams of solution, then I would multiply by 5. Question 7b says, I want to make 250 grams of solution of KCl at 20 degrees. Okay, KCl is my red line. I'm at 20, and so boom, right there. So that's like 29 grams. Well, 250 grams of solution, so I would take 29 times 2.5, or I can set up the proportion. And so the answer there becomes 72, sorry about my writing, 72.5 grams. Alright, so that's how we answer those questions. On the back, the part I want you to try, you're just using this graph. And this graph is the same as this graph, just has more lines on it. I have more substances on the solubility curves. So go through the questions and we will check those out together. Good luck.